Hey, what's going on, guys? Let's look at this problem right here. This question is asking a telephoto lens consists of a combination of two thin lenses having focal lengths of plus 20 cm and negative 8 cm respectively. The lenses are separated by a distance of 15 cm. Determine the focal length of the combination, distance from the negative lens to the film plane, and image size of the distant objects subtending an angle of 2 degrees at the camera. Now let's note down the given informations. So here we have two thin lenses. So let's say this is plus 20 centimeter, f is equal to plus 20 centimeter, and we have another lens that the focal length is equal to negative 8 centimeter, and the lenses are separated by 15 centimeter. So the distance between these two is 15 centimeter, 15 centimeter, and okay, so they are asking to determine the focal length of the combination. Okay, let's say this is f1, this is f2, and let's say the focal length combination is f, and let's say this length is L is equal to 15 centimeter. Okay, so the equation that connect all of these together is this one. The combination formula 1 over f is a combination focal length, that is equal to 1 over f1 plus 1 over f2 minus L over f1 f2. Now let's go ahead and plug the values. 1 over f1 is the focal length of the first lens, that is 20 centimeter, plus focal length of the second lens, that is negative 8 centimeter, and we have the length, that is 15 centimeter, divided by 20 times 20 centimeter times negative 8 centimeter. Now let's try to simplify this one. Here what we can do is we can take 40 as the common denominator. So if I take negative 40 as common denominator, this is going to become negative 2, and this is going to become positive 5. And here we have this one. Here we can simplify this one. This is going to become 3 over 4 times 3 over 4, and this is going to be negative 8. Let's simplify this one right here. This is going to become negative 7 over negative 40, and here we are going to have negative 32, 3 over negative 32, and let's see whether we can simplify this one furthermore. Negative 40, negative 32, this one here, and let's try to combine these two together. So negative 7, negative 32, the common denominator can be 30 times 40, 120. Okay, so 20, negative 8, 20, negative 8, this one. I should have done one more thing, like I should have keep 20 times negative 8 as the common denominator. So let's get rid of this thing and do the calculation again. So if I kept 20 times negative 8 as the common denominator, this is going to become negative 8, and this side we are going to have plus 20. Okay, minus 15 over 20 times negative 8. In that way we can add them together, right? And here you can see this is going to become 12 over 20 times negative 8 minus 15 over 20 times negative 8, and 12 minus 15, that's going to be negative 3. Negative 3 over 20 times negative 8, that's going to become negative 160, and this is 1 over f. So f is going to be 160 divided by 3. 8 times 2, 16, yeah, 160 divided by 3, and that's going to be equal to 53.33 centimeter, and this is the combination focal length. Now the next question is, what is the distance from the negative lens to the film plane? And when we consider this lens, for a telephoto we consider the object is at infinity for the first lens, So if the object is at infinity, the image is going to form at the focal point of the second length, focal point of the first lens, that is 20 centimeter, and the focal point is going to be 5 meter away from this. So this is 15, so 20, so this distance is going to be 5 centimeter. Okay, so if this is 5 centimeter, the image is going to be the object for the second lens, so that is 5 centimeter away from this lens, and this is in the negative side, right, because this is back side, so that's negative side, so the object's distance for the second lens is going to be negative 5 centimeter. Now from this one we can find the image, the distance from the negative lens to the film plane. Okay, now from this one we can find the image distance using this formula. 1 over f2 is equal to 1 over s2. So let's say this is s2. 1 over f2 is equal to 1 over s2 plus 1 over s2 prime. Since we are trying to find the image distance, we can rearrange this equation like 1 over s2 prime is equal to 1 over f2 minus 1 over s2, and here we can, if we flip this around, this is going to be s2 prime is equal to f2 times s2, f2 times s2 divided by s2 minus f2. Okay, and this is the equation. Now let's go ahead and simply plug the values. So I'm going to continue this one right here. Okay, this is going to be s2 prime is equal to f2 times s2. f2 is negative 8 times s2 is negative 5 divided by s2 is negative 5, and then f2 is negative 8, so minus 8, and if we simplify this one and find the final answer, that's going to give us 13.33 centimeter. So this is going to be the image distance from the second lens. Now let's see what else they are asking. They are asking what is the image size of the distant object subtending an angle of 2 degree at the camera. To find that one, we can use this formula, that is tan whatever the angle. So here we have 2 degree, so tan 2 degree is equal to h prime over f. Here we are trying to find the height, so height is going to be tan 2 degree times f, and we found out that combination of lengths, focal length is this one, 53.33. so tan 2 degree times 53.33, if you multiply that one, you should get 1.86 centimeter, and that's going to be the size of the image. I hope this helps. Thanks for watching.